Welcome to the NASRC Natural Refrigerants webinar series, where we highlight technologies and services that support the successful transition to natural refrigerants. For today's session, someone who really needs no introduction, Ed Esberg, who will be presenting on natural refrigerant technologies for food retailers. This webinar will review considerations and system options for retailers, food retailers, when transitioning from HFC refrigerants to natural refrigerants. So this is especially relevant for potential applicants of the CARB FRIP program. For those of you who don't know Ed, he was with Raley's Supermarkets for 30 years, over 30 years in total, both as a refrigeration consultant and the director of facilities. His presentation is really geared towards those small independent food retailers who need a straightforward, basic, objective perspective on replacing existing equipment. So, many of the presentations later in our series will cover in more depth some of the technologies he's going to go over today. We'll have time for Q&A. So all attendees are currently in listen-only mode, and the session is being recorded and will be available on demand. And the presentation slides will also be available on our website. You can, two options today. You can either submit a question through the Q&A chat and we'll address them at the end of his presentation, or we're gonna try something here. If you have a question that you'd like to speak on, we'll raise your hand and we'll try unmuting you. And so if that works, then that can we'll try that option later. Last thing, we've got more webinars coming up in our series here. You can view these online and register and view the full schedule on our website and sign up to subscribe for future updates. So with that, I will hand things over to Ed.
Thank you, Danielle. This presentation is, as Danielle mentioned, mostly about remodels and transitioning from synthetic refrigerants to low GWP refrigerants. And before we get into the real technical side of this, I want to talk a little about some considerations that you should be thinking about to make this transition. And the first one is the store that you're thinking about. Is it a winner? Is it a high volume store? Is it in your long-term plan for your chain or as an independent? You want to make sure that that you're putting your money where you're going to get a return. And historically, putting money into existing high volume stores has generally paid off. Keeps competition away, keeps your customers happy. It's generally a good idea to reinvest in your good stores. Second thing to consider is the equipment that's there that you're taking out now. Is it fully depreciated? Or is it free of any financial obligations? Did you lease it? Did you finance it? Whatever those considerations are, you want to understand that so that if you take it out before it's fully depreciated, you have a big write-down on your financial statements. It's not a game changer, but it's something you really need to consider. And then the other thing to consider is your lease. You want to make sure that you have at least enough term on your lease to allow for your depreciation. So that if you're depreciating equipment over 7 or 10 years, you need to make sure that you have that much time on your lease. This also might be a good time to talk with your landlord about your lease. You may want to sign up for maybe another 5-year term in exchange for the landlord committing to paying for part of the remodel. Or maybe he'll do some upgrades on the outside, put a new front on your store. Any number of negotiations are there. He can participate in the cost of the remodel for you giving him more term. At any rate, it's important that you make sure that you're protected. You certainly don't want to get in a position where you do a remodel and 2 years later, you have to go in and start negotiating a new lease. The landlord knows you've just put 4 million into this building. He's got you over a little bit of a barrel. So look at your lease, make sure you're up to date and are happy with the way it is structured. And then of course, make sure your landlord is on board with the remodel. He needs to know you're going to do it. He needs to know it's okay. It's just part of having a leased building. Obviously, if you own your own building, you don't have these concerns, but a lot of grocers lease the building, so make sure your lease is in good shape. Next slide, please. Then there's some just general logistic things to think about. You don't have to get very detailed on this, but you need to figure out, is a room on the roof for additional equipment? Will the new mechanical equipment go into the existing machine room or a new machine room? You don't have to get into the structural and all the details, but you need to have some idea of how you're going to do this remodel. And then there sightline restrictions. Is there a luxury apartment building next to yours, high-rise apartment building next to your store that they don't want to look down on new equipment on the roof? These things need to be ferreted out and just have some idea how you're going to deal with them. And then the last thing is really a pet peeve of mine, and that is to have a very defined scope of work. Is this a remodel where you're just doing an environmental upgrade? You're trying to get to an all-natural solution? All the cases and equipment's going right back in the same location? If that's the case, it's a very easy remodel and easy to do. But your operations people are going to immediately say, well, we're tearing up the store, we're moving equipment, let's move the produce from the back to the front, frozens from the corner to the center, or the meat department from the left to the right. Once you get into that, then you're into a much bigger remodel, and you really need to have that defined and kind of stick to it before you start, and make sure your people understand why you're doing this remodel and what it's all about. There's this thing we call scope creep, and you start a job and then the one department says, oh, I need new decor over my new dairy. And you put new decor there, and then it makes the other decor look so bad you have to end up doing a whole decor job. Or a guy wants the floor fix over here and it makes the rest of the floor look bad. At any rate, scope creep is a real problem and it can drive your costs up dramatically. So having a very defined scope of work and sticking to it is a valuable tool in controlling your costs. Next slide, please. So then there's some best practice issues. This new natural refrigerant or low GWP refrigeration equipment has sophisticated controls, and you need a service company that can deal with, if you go to CO2, can deal with CO2, or at the very least has the ability to deal with the sophisticated control systems. If we want to help your existing contractor to make sure he's trained in this, that's fine. If you decide to change service contractors, I would recommend you do it prior to the remodel so that he knows and can see what's going on during the remodel and is familiar with the equipment as soon as he has to take it over. But having a service company that can really deal with the more sophisticated controls and regulators and valves and cycles is a valuable thing to have. I would strongly recommend that you have remote communications via the internet. A lot of people haven't done that. A lot of people have. There's always this security issue, whether you hook it up to the company's network. And if that's a problem, just pay the $50 a month and have Comcast or whoever your provider is drop a dedicated line to your controller. But with these sophisticated controls, it's very important to have remote communications. A lot of diagnostic work can be done. A lot of service work can be done. And then you have the ability to graph things and see what happened when there's a failure. And then a minor thing, you're going to be disturbing your customers. You're going to be disturbing your employees. You're going to make their life miserable for a few months. Put some signage up telling them why you're doing this remodel. If it's just to refresh the store and make a better shopping experience, that's fine. If you want to tout your environmental position and you're doing something good for the environment, a little signage scattered throughout the store is a really small investment to make your employees and your customers understand why you're doing this remodel. Okay, next slide, please. So the first technology thing that's become available now is what we call conventional, or in the old days, we called them one-on-one, where you had a condensing unit, 2 through maybe 7 tons of capacity, generally dedicated to one load, one lineup of dairy cases, one lineup of deli cases or meat cases, one for a produce box, one for a meat box. They're now available in CO2, which is an all-natural solution. Generally, these work well in convenience stores where you have one medium temp box and maybe one low temp, or a regular retail corner grocery store, probably under 10,000 square feet, with 6 or 7 or fewer refrigeration systems. These are now available in CO2. They're probably also going to be available soon with A2Ls. But right now we're talking about CO2. Can we go to the next slide, please? Some of the considerations for these units. First off, they're really easy to install. You set it on the roof over the equipment. You run electrical to it. You run lines down to your fixture. It's a relatively easy thing to remodel and use. They come either air-cooled or adiabatic gas coolers or condensers. A bunch of these are probably a little less efficient than a multi-compressor system where you can have a much better control strategy. They still require a well-trained technician. They still should have remote control so you can see what's going on. These units generally sit on the roof. They're a little harder to get heat reclaim out of these, and we're going to talk about that in a minute. But it's something you might want to think about, is having heat reclaim with these units. But this is going back to the 1960s when I got into this business. Everybody did one-on-ones before the parallel racks came out. So this is still a consideration and something you should be aware of that's now available in the marketplace. And will become more available as the convenience stores and small corner retailers start having to convert to natural refrigerants. This will be a growing piece of equipment, a growing market for this equipment, and more people will get into it. Next slide, please. The next option you have is what we call secondary cooling. You can either circulate liquid CO2 or thermal siphon CO2. You can circulate glycol. So I know some grocers are circulating glycol with this. One of the big reason people do this is they don't want to compress CO2. There's a large segment of the grocers who are not happy compressing CO2 with the high temperatures and the high pressures. These systems work on a much lower pressure, 400 pounds on medium temp, maybe 200 pounds on low temp. And this offers a lot of flexibility in making a conversion to a CO2 or a natural refrigerant system. Generally, these would be used when your existing mechanical system is in good shape. Let's say you put it in 10 years ago, it's been trouble-free. Mechanical systems last 15, 20 years, 25 years. Or maybe you just put a new condenser on your one or new controls, and you feel it has more than 7 years of life. It's really hard to just throw that money away. So these devices you can put on the roof, hook them to your existing HFC system, and on the evaporator side, what goes in the store would be CO2 or glycol. In this case, CO2, excuse me. In this case, CO2. If you want to just change 1 or 2 lineups, let's say your frozen food, your produce cases are rusted out, and you want to just do a produce remodel. You can put one of these on the roof, hook it to your system, and then everything in the store will be new with CO2. And it's a very easy remodel to do. These are mainly used on full-size supermarkets, 15,000 square feet or above. And generally where you want to keep your mechanical system. From an economic standpoint, it makes a lot of sense. And we can talk about that in a minute. Let's go to the next slide. There's some considerations here. First off, this is a very cost-effective way to do a major remodel where you can save the machine room. When you do a full remodel, you have to put in a, let's say, a CO2 transcritical. You have to have both systems running at the same time, which means your electrical system has to be altered. You have to build either a new machine room or put a machine house on the roof and have the structural costs of doing that. With this, you can put 5 or 6 of these on the roof. Each one of these medium temp does 260,000 BTUs medium temp, 125,000 BTUs low temp. So maybe you have 3 or 4 medium temp units on the roof and 2 low temp units on the roof connected to your existing system. You don't have to build a new machine room. You don't have to buy a machine house. You don't have to do the structure to support it. And then when you do the remodel, you just take one line up out, you disconnect it from your rack, hook it to your CO2, and the load is automatically shifted to your rack. So it really has some advantages. The main drawback is to the retailer is that sometime in the future, you're still going to have to deal with converting your high side to something else. Some of the features that's built into this, and you might notice that there's a little condensing unit on the front. That is there just as an auxiliary unit, and it's connected to plate heat exchangers that have 3 circuits on the inside, one for the primary, one for the CO2, and one for the auxiliary. So you don't have an additional heat exchanger. It also has a built-in auto purge system, so that if you get non-condensables into this system, the system automatically purges those non-condensables out. It doesn't create a service call. That same system is also used as a controlled release system. If under a really extreme circumstance, the generator failed, the little condensing unit failed, and you had a power failure, as the pressure gets up in the vessel to 550, it has a solenoid and you can bleed off through a cap tube small amount of CO2 and control the release. So maybe you'll lose 5, 10, 15 pounds of CO2 over a 12 or 14-hour period and keep the system running. You don't end up dumping the entire charge. Then the only time that you have a major release from your relief valves is if there's truly a catastrophic event like a fire or something that you can't control the release on. Anyway, there's a lot of features for these. They make the transition to do it partially or full a lot easier to do, but you still end up having to deal with the high side gas eventually, the primary gas eventually. So it's just something to think about. This particular unit was made specifically for Rayleighs. I know there are other companies who are doing it. You can do it with glycol. There's lots of options here to keep your existing machine room and save that value. And some people list that value at close to $1 million by the time you buy the equipment, build a machine room, fire sprinklers, additional electrical, all that stuff. So it can be a substantial amount of money. All right, next slide, please. Another option is, and a lot of you are probably familiar with this, is a full transcritical CO2 rack. 1 to 4 racks on the store, depending on the size of the store and your appetite for risk. So that if one rack goes down, do you want the whole store, all the refrigerated product to be at risk, or just 3 or 4 lineups? So that's something you decide, whether you have 1 or 3 or 4 racks. You'll have 1 or more remote gas coolers or condensers. The compressor racks can go into a new machine room, or if you can shoehorn them into your existing machine room, or you can buy a mechanical house and put it on the roof. But then you got the structural work to do to support that. Generally, these applications are for large remodels. And generally, when your existing mechanical equipment is really junk and you're tired of dealing with it, and it's 20 years old or older, it's the end of its life, you want to get rid of it, you want to do a full remodel, this is the way to go. And generally, supermarkets, 15,000 square feet and above, where you want a rack type system, this applies pretty well. Next slide, please. So one of the good things about this is it's future-proof. You put a CO2 transcritical in, at least under today's regulations, you're pretty safe from having to deal with anything coming up. They're a little more complicated. You will require a full building permit. You're going to have some structural work done. Whether you put it in the existing machine room or new, it gets more complicated. And then during the remodel, it is more complicated because you have to run 2 refrigeration systems at the same time as you're taking loads off and putting them on. It just takes more planning, and it's more disruptive to your employees and your customers. It is probably the most popular option right now. A lot of the bigger chains are just decided to go with transcritical, do it one time. But that's an option you have with the other options. Okay, next slide, please. And then our last option is propane. One thing we didn't mention is that the natural refrigerants, there's only 3 of them that are really ready for prime time. R290 propane, ammonia, and CO2. They all have their problems. Propane obviously is flammable. Ammonia is obviously toxic, and CO2 operates under very high pressures. And so they all have their drawbacks, but these are the 3. We didn't cover ammonia, but ammonia could be used in the secondary system configuration. But now the propane, mostly it's micro-macro distributed. That's what we call it. Basically, you have a compressor or 2 on each case, maybe 3. Very small charge, 150 gram to 500 gram R290 or isobutane, but mostly in the supermarket, it's R290 propane. You use an air-cooled water loop or a chilled water loop to reject the heat outside. You have 2 or 3 compressors per case, 2 or 3 refrigeration systems per case. So conceivably, you could have 100 to 250 compressors in your store. And that's something that you have to consider. There can be considerable maintenance and energy costs on those. But it has been done. It's been done successfully. So it is an option. Can we go to the next slide, please? So some of the consideration to think about, the current studies that we've looked at show that there's a substantial energy penalty with these types of systems. Now, if you got a small store, you got 3 or 4 lineups, the energy penalty may not be a big deal. Or if you're in Texas where you're paying 5 or 6 cents a kilowatt hour, may not be a big deal. But the penalty in California and New York, some of these other places, is substantial. It's just something to consider. I think this is a good application for small format stores. It's really an easy thing to do on a remodel. You can put the water loop system in and then change the cases out at will, plug them in, start them up. It's a lot easier than a transcritical remodel from an operation standpoint and disturbing your customers. But it is an option, and it does come with some penalties. Heat reclaim is a little harder to do with this type of system. And one thing on the incentive programs, at least on the FRIP program, you can't use self-contained R290 cases because they're already mandated. So if you're going to use R290 cases, they have to have a remote way to reject the heat to the atmosphere. So that's pretty much my presentation. One thing I'd like to point out now is that all of these systems that we have talked about use more energy. And to offset that, some people are saying that their transcritical systems are better than their HFC systems. But I believe that the HFC systems they're comparing to them were old, were probably out of tune. They had old cases that weren't very efficient. There's a lot of things that affect that efficiency. But if you look at all the studies that I've looked at over the last few years, you can generally say that all of these low GWP or natural systems use a little bit more energy on the electric side. So that being the case, I would recommend strongly that you consider an enhanced heat reclaim system. There's about 600,000 BTUs for space heating, maybe 150 to 200,000 BTUs for domestic hot water. Your average full-size grocery store kicks out maybe 1.2 million, 1.3 million BTUs total heat of rejection. So before you buy any energy for the BTUs for space heating or domestic hot water, I'd strongly recommend you get all those BTUs out of your refrigeration system that you're rejecting into the atmosphere before you spend any money on energy. So with that, I'll conclude my presentation, and we're open for questions. Thank you.